Hello friends and welcome at my channel. Today I would like to show you a few more trigonometrical identities. This is the first we start with, which is going to be useful also with 3 others for our future exercises and theorems. So, as you remember, I'll link it also here, we've done the formulas of cosine of alpha plus beta, which was cosine alpha cosine beta minus sine alpha sine beta, the first. And the second was cosine alpha minus beta. Well, pretty the same, but with plus. Not intuitive if you see it for the first time or trying to memorize it, but since we prove it, everything is, well, getting better. What we're trying to do now, we are trying to rewrite cosine of alpha as cosine of, now look, alpha plus beta divided by 2 plus alpha minus beta divided by 2. That's nice, isn't that? And the same we're also doing for the cosine of beta, which is cosine of beta plus alpha divided by 2 plus beta minus alpha divided by 2, right? So let us consider those two, let us expand them and see maybe we can add them. Alright, so what is the first line? The first line going to be cosine of the first angle times the cosine of the second. We have plus, so minus sine of the first times the sine of the second. What about the second line? The second line is actually the same, but we are having cosine, well, alpha plus beta or beta plus alpha doesn't matter. Let's write beta plus alpha divided by 2 times the cosine of, well, I just want to make one more remark here. That's why it's fine to write it this way. And then minus sine of beta plus alpha divided by 2 times sine of beta minus alpha divided by 2. Now look what's happening. If I add them together, alright, so I can rearrange alpha and beta, doesn't matter for plus. It does matter for minus, so I have to have, so cosine of beta minus alpha divided by 2 is the same as the cosine of alpha minus beta divided by 2, but with minus in front. But the cosine, as you remember, is a symmetric function considering the y-axis, so the minus is gone. That means we basically have cosine of alpha minus beta divided by 2. So we can change it easily to cosine of alpha plus beta divided by 2 times the cosine of alpha minus beta divided by 2. We're not changing anything at all of the value of this expression. Now with a sine, we're having minus sine of, well, rearrange the sum, it's no problem. What about here? Well, here we would be putting a minus in front, the same as here, but the sine is symmetric function considering the origin, so the minus is going to be taken away. Let me write it down here. So sine of beta minus alpha divided by 2. Sine is an odd function if you remember, so I'm writing sine alpha minus beta divided by 2, putting a minus, and because it's an odd function I can kick it outside. I must, or have to in this case, kick it outside of the sign, so it's sine of alpha minus beta divided by 2. So minus and one more minus here going to give us plus. Sine of alpha minus beta divided by 2. Alright? Now if you add this modified number 2 and this modified number 1, these are two kind of valid equations, which they start here. So basically, if I'm considering cosine of alpha plus cosine of beta now, I'm having this line and I'm adding it to that one. As you can see, we have two equal expressions here and here. That's why we have two of those. 2 cosine alpha plus beta divided by 2 times cosine of alpha minus beta divided by 2. And we have two equal equations with different signs. Here we have plus and here exactly the same with minus. So they're lost. And this is how we prove this very first statement. Alright, let's move on to the statement number 2. I'll just switch the page. So we are having cosine now of the difference of A minus cosine of B, and we're actually doing the same. Now we're applying this formula, which is cosine of the first cosine of the second plus sine of the first sine of the second. And we are just rewriting cosine of A. Well, now we want to write it as minus. So cosine of A is basically cosine of A minus B divided by 2 minus B minus A divided by 2. Am I right? No. I have minus B twice, right? And I'm having, okay, so I have to rearrange it. A plus B here and A minus B there. All right. To look it up, I didn't remember exactly what is the approach, but now we see it. Is it correct now? Yeah. Now we have minus. A is gone. Okay, so this is cosine of B, my bad. And cosine of A, well, I know what to do now. This is cosine of, well, it doesn't matter here, but it does matter there. Look at this. A remains, B is falling away. All right, so the same story. So what is the formula that we want to prove? Actually, it's now minus 2 sine of A plus B divided by 2 times sine of A minus B divided by 2. All right, and well, I must be honest, I haven't used this formula that much. I'm just, since I'm making new ideas or thinking about this stuff, I'm looking it up, and I found it's interesting and important in order to prove other things. That's why I'm doing it now. And as you can see, my philosophy is I cannot and I don't have to memorize. As a chess player, also, I'm not doing this. You cannot memorize all the openings, you cannot memorize all the formulas, but what you should know is how to move the pieces, how they're connected, and what is the idea of the game. If we're talking about chess, we're talking about mathematics, I'm approaching the same philosophy. So I'm saying I cannot memorize. As you can see, I have to look it up, the formula, but I have no proof. I just have the formula, and I have to prove. And once I proved, maybe it's easier then to work with. Okay, so let's give it a go. We are having cosine of A and cosine of B, so we subtract them, but we firstly expand them. So once again, I'm showing this is the first, this is the second. Cosine of B. It's the cosine of the first times the cosine of the second. I have a minus, so it's plus. Sine of the first, sine of the second. All right. Cosine of A. What do we have there? Cosine of the first, cosine of the second, sine of the first, minus in between, right? Sine of the first, to make sure now I don't confuse the signs, and sine of the second. All right. Okay, so if we now subtract, we want to subtract in this case, as you can see. So if we subtract cosines, that means cosine of A minus cosine of B, going to be what? Well, what is happening with those two, as you can see, this is the same as this one, and if I'm rearranging those two, I have to put a minus in front. The cosine is kind of killing the minus, so those two are of the same value with different signs because we're subtracting, so they're gone. What about here? Well, we have the cosine of A, which is minus sine of A plus B divided by 2 times the sine of B minus A divided by 2 minus the sine of A plus B divided by 2 times the sine of a minus b divided by 2. This is what we have. Now, if I'm moving the minus here, all right. Okay, now we see the mistake. It should be a plus here because we're working with a minus, so it's a plus. And so it's plus here, it's minus there, that's fine. But now if I rearrange a and b, I'm gonna kick one minus in front, so I have sine of a plus b divided by 2 times sine of minus a minus b divided by 2 minus sine of a plus b divided by 2 times sine of a minus b divided by 2. And that means we are kicking this minus in front and having actually two same expressions. So that's why we're having minus 2 sine of a plus b divided by 2 times sine of a minus b divided by 2. And this is what we have here. Times sine of a minus b divided by 2. Alright? This is now the second formula. And you know what? I think I'll stop it here and I'll do 2 more formulas in the next video considering the signs. Thank you guys for watching and see you soon in the next video considering trigonometry. Bye bye, all the best.